designed to advance different areas of technology, one of which is called CosmicWorks, which is focused on commercial space, the commercial space industry, and as was mentioned earlier by Dan from Digital Globe, recently entered into a partnership between In-Q-Tel's CosmicWorks, Digital Globe, NVIDIA, and Amazon around the SpaceNet data set, which is a large collection of Digital Globe imagery, along with vector data about buildings and features in those images. It's named in sort of honor of a project called ImageNet, which really helped advance the state of the art with computer vision deep learning, providing tons and tons and tons of high quality training data to train those algorithms. And sort of the last thing I'll mention with ways that OGC can expand is kind of in two areas. One, as was mentioned earlier, I think by Xiaowen and also Rose from Pitney Bowes, is how Geo can bring together lots of other types of data and data sets, right? Maybe I don't even care about geospatial, but the fact that data over here and data over here share a common place in time and space can help you link those two data sets together, right? That makes Geo more relevant than ever in this age of big data. And then in terms of, really, I think OGC can really broaden the aperture with respect to the kinds of organizations that it's engaging with, right? If you look at sort of what's happened in the last 10 or 20 years, geospatial has exploded. It is everywhere, right? Well beyond traditional GIS. If you look at the most widely used geospatial applications out there, it's Google Maps, yes. It's Tinder. It's Yik Yak. It's Uber, right? These are companies that did not come out of traditional GIS. Companies that have hundreds of millions of users, billions of dollars each year, billions with a B, billions of dollars each year being poured into technology development. But these are just, hapless data scientists and software engineers that are wandering into geospatial applications, and they don't have this background, right? They don't have this background. So I think there's a huge demand over here for expertise and a huge supply of demand, and maybe bringing those two worlds together would be really beneficial.
That's really good. Thank you. Okay, so let me just ask if the audience has any questions about the opening comments before I move into the other part of it. So, Xiaowen, I want to go back to you really quick because I've got, I talked about something at break, which I think is a demonstrative of a big data problem. A few months ago, I was honored to sit in on the Mapping Science Committee, and I saw a demonstration of a national hydrologic model being computed nationwide in 6 hours. And the bedrock of that is a fundamental change in the way I think the government looks at how to compute floods and hydrologic activity by using fundamentally LiDAR. Can you comment on the impact of that?
Yeah. So first of all, I could perhaps comment on a little bit about the sausage baking part of the story. Well, thanks for serving on the Mapping Science community, Mark. That was greatly appreciated. So the story here is what is called, as I said in the Q&A before, National Flood Interoperability Experiment. So this is a brainchild of David Maidman, who's a service hydrologist, GIS expert at UT Austin. I think he's chair of the Mapping Science Committee?
Yes.
Yeah.
He also
so
had
David,
great influence over WaterML.
That's right. WaterML also is a great contributor to the OGC community. So in the past several years, I started collaborating with David, but also David Tarbolt from Utah State University, who is an expert of analyzing digital elevation model data, which we know usually we have this desire to derive digital elevation model data from LiDAR data or other sources of terrain measurements. So as you heard earlier today about the USGS 3DAP program, which is producing this massive high-resolution LiDAR-derived topographic data sets for the nation. So we saw this opportunity in terms of deriving hydrological information from such high-resolution topographic data sets that would give us this holistic view of the country, incorporating topographic features for representing the potential flood. So you think about this. this is crazy and amazing, right? If we know all the details of our terrain features, we pour water on our terrain, and no doubt this is influencing how the water is going to be distributed. But we look at this holistically, as opposed to for hundreds of years, hydrologists look at this problem at a local, fragmented fashion, catchment level. So we think this big data, again, as I was emphasizing earlier, we should ask new questions, because new questions is going to be so exciting with the availability of this big data. And this is, I think, attempt of posing some new questions. Could we picture the flood potential from this top-down perspective based on this very detailed topographic feature representation? That's the big question.
Yeah, thank you. That's what really struck me was the fact that for the first time, we saw the improvement in computing power, getting us from almost a day to compute a national hydrologic model down to just a few hours, and the ability of something like LiDAR nationwide to be able to add a dimension of accuracy to that, so we can actually maybe predict a Texas, they either don't have water or they have way too much. These are situations where I think we may be able to make a significant step forward in our ability to predict and get assets and, more importantly, people out of harm's way when these events transpire. So what I wanted to do now, and maybe this is just as a litmus, just consider this a little bit of a chalkboard. This is a collection of ideas that are coming together from potential sponsors of our next testbed. And they've been expressed at a high level architecture. You'll notice we have everything from semantics, semantic mediation, semantic understanding, to sources and communities, in this case aviation, cloud computing, and over here big data. So not looking specifically at this, but maybe this is a guide. This is sort of a laundry list of things that OGC could be doing. What are some of the things we might be able to put up in that laundry list? I know, Leah, you talked about the regional organizations forming in the context of your project, and I saw a high alignment with about 5 or 6 domains that we work in. That might be one area where we can collaborate at the cloud level and the big data level between OGC and those regions, targeting very specifically some issues that we can work together to promote interoperability.
Yeah. For the hub, for the infrastructure working group, we're very much interested in doing some test bed activities, particularly connecting, end-to-end some of these tools that are available, but looking for use cases that would be good. Water, certainly a big interest, mobile health, as I said, and anything related to smart cities, IoT.
Jeff, anyone else?
Well,
Losing the technology.
Yeah.
now it's on. Okay. Yeah, well, when I look at this, what I'm drawn to under number 3, discovery and catalogs, just because this is something big we're working on already at NOAA and that we are required to work on by the government open data policy, and that I fear will become harder if people are no longer getting data from us, but are actually going out and trying to find the data to compute on that's now being held somewhere else. How do you find that? How do you know that the copy of the data that's in the cloud is actually the real copy or a correct copy of what's out there? What if we change something? How do you make that? How do you update the inventory in the cloud? I think that's going to be a big issue.
One of the other things that I picked up on was the work that we're doing in discrete global grid systems, a different way to look at how you deal with the amazing level of detail of information we're going to have to manage and how it temporally changes so quickly. That may be another piece of that. Charlie?
I mean, the thing that jumps out at me,
What do you got?
the thing that jumps out at me the most is the human geography up there in the top left-hand corner. I mean, obviously, in my community, activity-based intelligence is a very large interest area. And if you look at, all of these geospatial apps that everyone has on their phones are throwing off a ton of telemetry data, right? All of that data is being collected and monetized to serve you better and more relevant ads, right? But that's creating tons of big data that can be used for other things, right? So think of this example of where Google was able to see how people were searching for flu symptoms to sort of measure epidemiology, right? how can we look at the type of geospatial data that's coming off of all of these apps, whether it's Runkeeper or Pokemon Go or Tinder, right? And what sort of questions can that answer, right? Maybe different types of epidemiology. That's a joke. But, how many people know what Tinder is? I keep saying it, right?
I have no idea.
Do your spouses know? Don't Google it. But that can also feed into, right, we talked about Internet of Things, but Internet of Things doesn't have to be these weird devices. It can be just our smartphones out there in the world pumping out all this data that can open up, so many different use cases, so many different applications. But that's big data, right? 100 million people pinging how many times a minute? It's a lot of data.
Right. So sensor things comes to mind, one of our recently adopted standards to help mash up IoT telemetry, so to speak. There was a comment earlier, I think it was Jeff, and I caught it. You said you wanted, as part of the big data initiative, you wanted to move data to the cloud and challenge the crowd to extract more value from it. So in doing what you're doing with the big data activity, you're actually looking at third parties to be smarter than you. They're out of the lane, they're looking at the data for what it is, and they're trying to find new ways to do that. How do you think we might tie the crowd in? You know our testbed process really well. How do you think we might be able to tie the crowd in? Do you think we could build a challenge or some sort of a hook into your activity, into this testbed process, and enrich it?
Yes, I think we could. One challenge that we're having, which maybe we could solve with this testbed, is we worked with these 5 cloud providers. We gave them a bunch of data, figuring, they are going to go out and find people who want to compute on the data and make value-added products and services. And that is actually not going as fast as we would have liked. We realized actually they need more hand-holding. They need to better understand the data. We need to help them find the people who would work on the data. And so that's one sort of social connection issue that we need to figure out. The other is, if there's somebody who wants to compute on the data, but they don't want to actually pay for computation, if we can find a way to have cloud credits or some sort of test bed which lets them try things at kind of no expense, and then see if it works, and then keep it going at their own expense perhaps later. I know. Well, when I heard about the NIH cloud credits model, and I think that is a great thing, because it would be very easily.
I believe Digital Globe earlier brought up SpaceNet, and it was echoed here just a few minutes
Well,
ago.
I was just going to add, that's the raw data in and of itself is sometimes only valuable for a certain set of use cases, right? What often we want is some sort of enrichment to that, right? So that so we can use that as training data to train models to then do that enrichment automatically. Whether, like with SpaceNet, it's characterized buildings in a satellite photo, or what have you. If you look at it's often very difficult, time-consuming, and expensive to create those annotations, right? Enrich the data. Have humans do that enough so that the machines can learn from it. If you look at great examples that Google and Facebook have done with CAPTCHAs, where you're going in and click on all the road signs, right? You're training Google's self-driving car to be able to do that in the future. Is it not working?
No, I think that is itching to add to your conversation.
Oh, sure. But how can we get people to do that for this domain, right?
So, yeah, there we go. So for the last 7 years, I've been focused on crowdsourced data collection. The MapGive community, by the way, that the State Department ran, is about to expire. So you have a couple of hundred very active volunteers who need to be redirected to projects. So that's a group you probably could tap into right away. The Federal Community of Practice on Crowdsourcing and Citizen Science is now 300 members strong across 40 agencies after 3 years. Has full White House support. So that's another group that we could tap into, and through that, and the Citizen Science Association in the US and the Citizen Science Association in Europe. So you have some easy conduits now into those kind of humans in the loop.
So really good ideas. Sean?
Yeah, so looking at this diagram, I agree with all of the nice points made already, so it's perhaps not so much room for me to make 2 points. One point is as I see, the big data bubble is intersecting with all the other bubbles. One emphasis I see, for instance, current either testing beds or standards are not able to cover well, is this at scale services and the standards, meaning
At scale.
at scale. Could be.
Get rid of this.
Okay.
This is the offending mic.
So,
Sorry.
this is certainly true even from education side.
I'm not
When
sure
we
it's on.
teach students,
Go ahead.
so for instance, when we teach students about some big data problems, it's still not very intuitive to get them exposed to scalable data sets and the scalable algorithms. And when they go into industry, they still see a new world, right? And we need to bridge that gap. I think OGC could do something about it.
Yeah.
There are still missing standards interfaces along this scalability interface side. This is connected to parallel computing, computing new platforms, and new computational infrastructure innovation. So we need to bring the communities together.